Welcome. So this question says a 2 kilogram particle is located at +3 meters on the x-axis and 6 kilogram particle is located at +8 meters on the x-axis. The gravitational field strength is given by that minus 12 over x and newtons per kilogram, and then where on the x-axis is the center of mass, and then where on the x-axis is the center of gravity. So let's visualize first of all. So here's my x-axis is 0, and then at 3 meters, so +3 meters, we have a 2 kilogram mass. And then way out here at +8 meters, we have a 6 kilogram mass. And the first question is, where's the center of mass? And the way I visualize this is, you imagine this is a massless rod with these two masses attached, and you try and move your finger to the balance point. And if we imagine the middle position, then it's pretty easy to see that because of the difference in the masses, the balance point is going to be somewhere out there to balance these two guys. That's the center of mass, and that's what I'm trying to find. The equation is x for the center of mass is equal to the sum of xi mi over the sum of mi. And what that means is that you take each mass and you take its mass value and you multiply it by its distance by the origin, and you add all those up, and then you divide that by the sum of all the masses. So you do them in order. So we can say this would be 3 times 2 plus this would be 8 times 6 divided by, add the two masses together, 2 plus 6. So this would equal 6 plus 6/8 of 48. 6 plus 48 is 52. 54. I'm doing it in my head, you see, and that's not good. Over 8. Let me just double check that. I really should write it down in 2 steps, but my diagram's in the way. So that's 6, and that's 6/8 of 48. 48 and 6 makes 54. That's 54 over 8. So this is going to be 54 over 8. 5/8 of 40. 6/8 of 48. So this is going to be 6.75 meters. So there's my answer. And that's where I expect it to be. It's over to the right of the midpoint. And the midpoint, if you think about it, is 2 plus 2.5. Yes, 2 plus 2.5, 3 plus 2.5, which is 5.5 meters. And this is at 6.75 meters. So that's my center of mass. Now my center of gravity, that's a different point in this case, because I don't have a uniform gravitational field. My gravitational field is given by this, and we're used to having G equals minus 10. It points downwards, and it's 10 newtons per kilogram. And it's constant. Well, this is a gravitational field that as the x increases, it gets weaker. So if I imagine a gravitational attractor here, then this will have a very large weight, and this will have a really quite small weight, because although it's more massive, it is much further away. So the equivalent diagram might be, I'm going to draw things, this would be quite a big weight, so we'll draw that as an arrow downwards. outwards, and this would be my small weight. And so I can see now that intuitively I would expect my center of gravity to be over here somewhere. And let's check that out. So we say, well, X center of gravity is equal to, and it's almost the same equation. It's Xi. Let me change the order of that, just so that I'm used to doing it the other way. It's MIGI, that makes my weight, times Xi over, now not over the total mass, but now over the total weight, which would be MIGI. So now if I look at my diagram, I see that it's going to be 2 times minus 12 over my position, which is 3, times my position, which is 3. So rather than saying minus 12 over x, I said minus 12 over, and my x position is 3. Added 2, because it's a summation sign. And now I look and I say, well, my mass here is 6, and my gravitational field strength would be minus 12 over my position, and my position is 8, times my position, which is 8, divided by, it's going to be my mass times my gravitational field strength for the first particle, plus my mass times my gravitational field strength for my second particle. It's just numbers. Let's work this out. X center of gravity is equal to, well, let's have a look. Those 3's are going to cancel, and those 8's are going to cancel. So that will help us a bit. So this would be 2 times minus 12 is minus 24. Added 2, and 6 times 7 is 6 12s are 72, so that's minus 72. Divided by, well, 3 goes into 12 4 times, that's minus 8. And 8 goes into 12 1.5 times, so that's going to be minus 9. Minus 72 added to minus 24 is going to be minus 96 over minus 8 plus minus 9 is minus 17. So let's have a look. Minus 96 over minus 17. 96 divided by 17 will give me 5.65, which equals 5.65 meters. Which means, actually, I was a bit over optimistic. It's actually there. So it's not quite on the less than halfway side of the midpoint, but it's significantly closer. So this is the center of gravity. So 2 different possibilities. Near the surface of the Earth, the center of the mass and the center of the gravity are at the same point because we're in a uniform gravitational field. But if you imagine very large distributed systems of mass, like for instance galaxies or solar systems or the like, then when you get situations where the gravitational field strength varies significantly over the range of the problem, then your center of gravity is not in the same position as your center of mass. And there we have it.